aviation, both the global history as well as the history in the Indian context. So the two sessions today we will sort of utilize to cover some of the salient aspects, some of the important milestones in the history of aviation. First, the world history, and then the history of Indian aviation specifically. The first question is, why do we worry about history? We are going to analyze the elements, the systems that constitute airports in the modern era. Why do we worry about history? The answer to that is, history is the study of history gives a picture of the evolution of things, and history is actually from time to time how people, technology, societies, cultures, governments reacted to the current trends or reacted to the systems or situations at each point of time. So that in a sense, it's a guide. It can provide some pointers as to what are going to be the responses in future as well. So there may be lessons to be learned, there may be corrections to be made, there may be things to be adapted, some things to be rejected, etc. But either way, to have a basic understanding about the evolution of the technology or the industry will be useful for better gaining better insight to the modern requirements and the modern developments. So that's where we place the uh, uh, overview of history of aviation. As we know, there are several imaginative portrayals and stories, etc., which are available in the form of text, stories, legends, sketches, etc., which all are reflective of the human interest in flying. That is probably inspired by birds. Human wanted to fly and thought that it is feasible or it will be possible to fly. So many of the concepts or conceptual descriptions about aircraft, as we know about, as we see in, say, for example, in Ramayana, there is a very detailed description about Pushpaka Vimana. In fact, in Valmiki Ramayana, one full chapter is devoted to explain what Pushpaka Vimana is about, the look and feel of it, the capabilities of it, what you can see inside it, how it or is not how it works, obviously, but then what are the infrastructure or what are the facilities inside that, etc. So it's all reflective of the human imagination or understanding about the feasibility of flying. And that's not the only place. In other Sanskrit texts, also in Sanskrit literature, you can, in many instances, you can see the description about flights. For example, poet Kalidasa has given a description of how it looks like when you are flying, and when you look at the aerial view, when you look down, how it will look like. The appearance of rivers, the ocean, mountains, the land, forest, etc. A very detailed poetic description of how they look like. And then there are more recent times, there are sketches that are attributed to Da Vinci, which are representative of possible systems or what they considered as possible systems which can defy gravity and fly. And then there is a treaty called a text called Brihad Vimana Shastra. Probably you have heard of it. The title Brihad Vimana Shastra means the large science about flights. large science or the big science about of aircraft. That's what it literally translates to. So Sanskrit text gives a lot of description about what all should constitute the elements of an aircraft, how it should evade from attacks of enemies, and how it should find its direction, etc. Now, are they all physically feasible? I don't know. I have gone through some parts of it, some descriptions of it, or some actually the original text. I do have the soft copy of it. But then, can we relate that to the physical concepts that we are familiar with today? I'm not sure. So, but it provides what they saw as the science of aircraft, the science of flying in general. Brihadyuman Shastra, as they say, is a part of a larger text which is called the Yantra Sarvaswa, and it's attributed to the sage Bharadwaja. You probably would have heard about all that in your cultural studies, etc. They may have mentioned to you about the ancient knowledge, etc. So anyway, this is one of them. So I am just quoting it here because it's one of the texts which are considered to be ancient and attributed to the science or what they codified as science as related to aircraft. Now, coming to more modern times and more physical experience, or what we can understand as more physical experiments or attempts. There were these balloons which were which they themselves described as big, clumsy, and filled with gas of 19th century, but they are based on the concept of or rather relying on the buoyancy effect, where you have a lighter than air gas, that is filling a balloon and then floating in air and supporting a structure which can possibly house human beings. So very limited in their scope and applicability, but then there were several such experiments or attempts which were documented and carried out in the 19th century. And then we are aware about the Wright Flyers 1903, which is the first powered airplane that is larger than or heavier than air. The aircraft being itself heavier than air and being able to make a controlled flight. Details are there. The wingspan is such and such, wing area, length, etc. You can just go through them. I just take down them from the online sources. Anyway, that's, as we know, that's a first demonstrated successful attempt of heavier than air flight with a powered aircraft. So the key things or key success elements of Wright brothers is that balancing and steering the machine, that is to have a control over it than just being left to the direction of the wind. That is to be able to balance it as well as to be able to steer the aircraft in a direction that one would like to advance towards. So that's basically the control, and that's where this one that's why Wright Flyers aircraft is considered to be the first in the first successful attempt in the direction of powered flight. Okay, and then there were several attempts followed by that, and there were several subsequent demonstrations. I guess Wright brothers when traveled to the Europe to demonstrate their concept, and I guess it was widely received that time among the global scientific community. And then comes the World War in 1914. 14 to 18. And that was the time when the use of aviation was identified as a possible as of possible help in the battlefield as a military force. So for attacking the enemy, the potential of aerial warfare was first realized in World War, which resulted in large-scale manufacture of production of aircraft both in Europe and in the USA. France, Germany, England, etc. Pioneered the development, and many pilots were trained to fly them. Of course, they were when we look back today, they were all sort of primitive machines, but then they could as we just saw with the most important things, that is the steerability as well as control and the balance. They had the minimal capacity to fly, and suddenly and in the backdrop of the World War, the military value of aircraft was uh, quickly recognized, and that was that the military value was what inspired the development of aircraft to begin with. So it was related in the public mind. It was considered as something which can help bombing. So bombing was the primary objective. Bombing to drop a bomb from an altitude was considered to be the primary utility of aircraft. And please note that the whole effort there was focused on battle, and civil aviation per se was not considered to be anything important during that era. So after World War, if you put yourself into the issues of the community in that era, the scientific community or the aero community, there were several aircraft which were manufactured with the World War in mind. There were several pilots who were trying to fly them, and after the culmination of the war, and probably there was no use for them. Actually, they were all left around, and the pilots didn't have a job either. So then the question was how to make use of them. A lot of government funding has gone to develop them, to manufacture them, to train the pilots, to develop the technology, etc. But then how to make use of them was the next issue. In Europe, due to the war, a lot of disruption was there to the rail traffic. That is, the rail lines were damaged, and they were on the land. There were broken buildings, broken roads, etc., which were all as a result of the war. So the thought of making use of aircraft to bridge the gap or bridge the loss of rail traffic for long distance travel from the perspective of civil aviation was probably first started in Europe. So to make use of the otherwise unused military planes to possibly accommodate passengers, and also for postal service, that is for delivering mails, etc. So these two, that is passenger travel and delivery of mails, postage, were considered together in Europe. And as it is documented, the Air Transport and Travel Limited UK, the government funded organization, that acquired several single engine, single engine aircraft from Rolls-Royce Limited, and modified them so that they can have passengers inside than having just a very adventurous pilot. So it's like it was like adapting the battle, rather the war planes to suit the requirements of civil aviation in some primitive way. And then since that similar efforts also started in France, obviously there was some competition between France and Europe, and then government funding had to be put in again to have a means to compete with the French airlines in Europe. But as we see that this kind of an initiative came primarily from UK, France, and to some extent from Germany. But the US government, for some reason, was sort of averse to the utility of aircraft for civil transport. And they still considered it, or they still used it as a source for postage service, that is transport of mails. So US also made use of the left out aeroplanes, but then they made use it mostly for postal delivery, for the transport of mails. So in that era, that is now we are talking about in the time in 1920s, early 1920s, the U.S. interest was U.S. interest in aircraft, in aviation industry in general, was focused on as a means for transportation of air transport for postal delivery. And then comes the what we usually call as the first modern airliners, and Boeing built what which is considered as the first modern passenger aircraft, Boeing 247, I believe, in 1933. 1933. So we have that 1920s, as we have just seen, was primarily the governments trying to figure out what to do with aircraft, or what to do with air transport, and coining and toying with the ideas of postal service versus passenger service, etc. And then trying to understand how to convert the technology from something which was purely focused on military applications to suit the requirements of civil aviation. And the culmination of all these efforts was in the first half of 1933, and Boeing 247 is probably identified as the first passenger aircraft. First passenger aircraft can be sort of considered as a commercial operation, and which was a 10-seater one, and the flight speed was the cruise speed is recorded as 262 kilometers per hour. And then say a 10 passenger flight probably was a successful demonstration that say, the aircraft can be used for civil aviation as well, but possibly it was far from economic. And then continued efforts resulted in this 24 to 32 seater aircraft DC-3, 1936, with American Airlines, and that is considered to be as the first aircraft to fly profitably. That is, to make a profitable flight is identified as the first aircraft, DC-3, is by the Douglas Aircraft Company. DC-3 by the Douglas Aircraft Company is identified as the aircraft to make a first commercially meaningful or profitable passenger flight, and that was as late as 1936. So that is from the inception of World War. Now, 2 decades have passed when they have actually established, in some sense, technologically it's established that commercial or profitable civil flight is possible. And then, so we were 1930. So any questions or any points that we should revisit or discuss further in whatever I mentioned so far? Okay. Then we have World War II. It's a sad truth that whenever we talk about advancements in uh, several technological segments, particularly in aviation, many of the major advancements were related to wars. They are either related to war times or related to the requirements of the wars. So wars, as we know, are aimed at destruction, attack, though we often call it as for defense. Mostly the designs and the developments or significant advancements will be aimed at offense for attacking. So destruction is sort of inevitable part of any battle, any war. But unfortunately, what has been driving the some of the uh, advancements in aircraft technology in particular has been the wars. So we have seen that it was World War I which sort of gave an impetus, which sort of gave an advancement to the technology that Wright brothers developed in 1903. And then a further advancement in the field resulted after or following the experience of World War II. So again, in 1939 to 43, during World War, US was very active in producing aircraft, all for the battle, for the military purposes. Because by then, the potential and the ability and to some extent the inevitability of aircraft as a weapon, or rather as a source of weapons, was realized well, and then rose from 3,000 to 50,000. So you can see the increase, the dramatic increase in the number of aircraft productions. That is, in 1939, or by 1939, they were making about 3,000 aircraft, and that rose to 50,000 in the span of 4 to 5 years. 4 to 5 years. So that kind of an emergence of technology or emergence of the application of aircraft technology was a result of the World War II. And as we know, the dawn of jet engines. Again, the jet engine, the concept of jet engine, as well as the development and the funding, the technology, the engineering expertise that went into the development of jet engines, etc. They were all primarily driven by the necessities or the requirements associated with World War. 1939 to 44, there were several experimental studies, analytical studies, and demonstrative studies, which led to the final development of the jet engine. And there were further developments. So we know that jet engine, the concept of jet engine was an outcome of the World War II era. And then further developments in in the 1940s, 50s, and 60s, actually even in 70s, were all driven by the requirements were there on the civil aviation side. Civil aviation kept progressing at its own pace, but there were military military requirements as well. Though we did not have a war after World War II, a major war. That is, we didn't have a world war per se after World War II, but there was still the tension between USSR and United States. USSR, the uh, Soviet Republic, which was sort of disintegrated in 1990, early 90s, 91, 92, to be more precise. So the Cold War era, where there was a lot of tension between enmity between USSR and US, also resulted in the advancements in aerial technology, because it was considered that anytime you may have to be prepared for an aerial attack. Whether we like or not, that kind of animosities fueled the technology, or dictated the terms at which the aerial technology grew in that era. And then Boeing 747, an important milestone. It's sort of considered to be something which sort of revolutionized aviation history because of its sheer size, seating capacity, and profitability, etc. Distinct upper deck, etc. Then go through the details of it. Seating of for as many as 450 passengers, and sort of doubling the capacity which existed till then. Made use of a Pratt & Whitney J890 engine. A turbofan engine with a bypass ratio of 5, which is fairly high at that point of time. So that it was all a new approach, or a sort of a revolutionary idea at that point of time, and which sort of expanded the scope of civil aviation as a whole. So 747 stands is another milestone in the history of aviation technology as such. And on the in the background, there was also a lot of effort going on in improving the flight velocity. What should be the maximum the flight's velocity that can be achieved? And as we know, 1947 supersonic flight was achieved, but that was with the help of a rocket engine. But at least it demonstrated that yes, we can fly at supersonic velocity. So there was further research going on how to make use of supersonic flight for commercial aircraft, and there was a lot of collaboration, particularly between France and Britain on that. And Concorde, as we know, is a culmination of all those efforts, where you could actually achieve supersonic flight in a commercial way. So you could have commercial flight with a supersonic velocity. And then, but that was, I guess, the period through which Concorde flew, if I remember correctly, 1976, possibly. I guess 1976 was the first. It was demonstrated earlier, but then I guess the first commercial flight was in 1976, and we know that they had to stop flying in 2003, and that's the reason. The reason for that is from several corners. One of the major issue was the viability, the financial viability, environmental considerations, then noise, etc. were all contributed because they didn't have, apparently they could not fly on over land and at supersonic velocity. So supersonic velocity has to be had to be restricted to flight above ocean because of the noise pollution that is caused. And then fuel efficiency was on the lowest side because it had to rely on an afterburner for which the thermal efficiency is very low. And then overall, the cost of flight was very high. So unless people are prepared to pay that high ticket fare, probably it didn't make sense to have a supersonic flight. And the question is, yes, there is a time saving, significant time saving possibly when it flies at supersonic velocity. But then the distance that it could travel, it could cover with supersonic velocity was limited because supersonic velocity could be achieved or could be deployed only for only while flying above the ocean. And not only that, that the delta savings in time, when you consider the total time required for the travel, probably was not sufficiently high to justify the additional cost that as a passenger one has to pay for it. So there could be several reasons for why they had to stop in 2003, and more importantly, why they don't have in the last 2 decades a successor for Concorde. So we know that even now Boeing, I mean, they're still struggling to come up with an alternative, probably a smaller aircraft, etc., which can fly at supersonic velocity for commercial purposes. So that's another milestone as far as the technology is concerned. And then in the list of milestones, I would like to also just add this Airbus A300. I have left a video here. I probably will play that later, but that just gives some insight to what happened to Concorde, and I guess it's an informative one from the perspective of technology, the history of aviation technology. Anyway, the world's first twin-engine wide-body airliner, which made use of a turbofan engine, the A890. Airbus A300 is also an important milestone, and there were successive variants for that, A310, A320, etc. So these are the kind of aircraft which sort of led us to what we are currently in the field of civil aviation, in the field of commercial aircraft. And in 1980s, and more so in 1990s, and probably continuing through 2000s, one of the important changes that occurred in the industrial segment was there were several consolidations, that is mergers and buyovers, etc., within among the companies, both in US and probably more predominantly in the Europe. So many manufacturers merged and actually smaller companies became part of larger companies, etc. Because the aviation industry actually was going through several financial challenges, and we know they are still going through. The current challenges are different, but then many of them were common actually, because the investment and the profit, the revenue of aviation industry as a whole kept increasing, but the profitability did not increase at that level, and actually many times it was in loss. So That's what resulted in several consolidations in the industrial segment, and that's a different branch of study altogether. We probably won't go into details of that, but there were issues related to the financial viability of operations, which resulted in several consolidations among companies in 19. I guess it started in 1980s, but grew considerably in 1990s and to some extent in 2000s. I guess I will stop the lecture today here. I'll also require some time to explain about grouping of the class, and then subsequently we'll have the presentations by teams on selected topics, on topics that I will give, which will be part of the continuous assessment. Before I go to that, if you have any questions, you can please raise them. When I say questions, actually this whole subject not being technically demanding, etc. We don't have too much of analysis, etc. So it can be even thoughts that you have probably differently from what I mentioned. So it could be more like discussions about your perspectives, and that's actually what I want to highlight when we have the class presentations also. So if you see, or if you want to add to anything that I mentioned, or if you want to say something differently or look at something, state something differently from what I mentioned, that also can be brought out in this discussion session. Okay, I made some teams. In fact, I wanted to have actually when we were hoping to have the offline classes, my plan was to have more like group discussions, which will be more in line with the management tone of the subject. So I thought we can have uh, more than presentations, debates or discussions within the class with dedicated sessions. But then with an online mode, it's very difficult to have that, at least as much as I can foresee. So I'll revert back to the class presentation mode. What I would like to have is we probably will have regular presentations. We'll devote some time from each class for class presentations. So that's why I have made the teams. I keep it simple. I just made 4 teams out of the total 28 students. Team 1, 2, 3, 4, and then I'll give maybe next session onwards. I'll give the topics team by team. One thing I want to highlight is that when I say presentation, it can be, say, 5 minutes, 6 minutes, 7 minutes, max 7 to 8 minutes. Okay. So, it's not that I want you to put each team, it's not that I want you to put a lot of time to it in preparing, etc. Any material that you can get, I mean, readily get from the net or any other source will be good enough. But then put that in a proper perspective when focusing on the subject that is given, and then present it. So maybe a few slides, actually 5, 6, 7 slides, depending on the topics. So it's not that I want to take a lot of time of you in preparing the presentations, but more for attention should be on how you present it. And I would expect that you work it out, each team work it out as a team activity, so that say if I give one topic is given, when a specified topic is there, you can look at many the various members of the team can look at various aspects of it, put them together so that each person don't have to spend maybe more than 15-20 minutes for preparing for it. So that's what I want to clarify, because these will be repetitive. It won't be just one-off presentations. We'll have, in fact, ideally in all sessions, I would like to have some time devoted to student presentations. So I'm just giving you how much time should go into the preparation. One. Second is the easiest way that I can make teams and the easiest way that I can enter marks in AUMS, etc., is if I just follow the order of roll numbers, and that's what I've done here. I just listed the names just based on the roll numbers. Just split that into 4 teams. The last team has a re-registered student also, so that's what makes 28. Sorry. I know that there were some students who wanted to audit. I would exclude them from the presentations, because this is part of assessment and they don't need to be part of the assessment. So of course they can attend it, but what I'm saying is they don't need to be part of the teams that make the presentations. So that's how I have made the teams. Now, if anybody has any strong concern, I hope will not be there, but being part of one team and would rather be part of another team, etc., they can probably let me know and I will try to accommodate that. And now the topic distribution we'll have starting from the next session onwards. And I stop here. If you have anything to comment on anything that we have discussed so far, including the presentations, the mode of presentations, teams, etc., please. Again, I'll be, as soon as this class is over, I'll be uploading this PPT on MS Teams. So you please check and make sure the team that you belong to, so that when we have the topics discussed, it will be easier to for you to know what you are supposed to work on.
Sir, you said that this team presentation is a repetitive task, sir. So does that mean every person will get a chance to present, or we have to present every time?
Say, since it is going to be a short presentation, I would leave it to you for a given presentation. I leave it to you, the team. You want all the 7 members to be presenting, you can do it, or maybe 1 or 2, that's also fine. 2 or 3, that's also fine. Even 1, that is also okay. But then, yeah, say if it is only 1, then in the next time when that team gets a presentation, I want necessarily to be going to another person. It should not be the same person presenting it all the time. So ideally, it may be a good mix to have 2-3 people presenting once, and then a different 2-3 people presenting it next time when the same team gets a chance.
The duration you gave was 5 to 7 minutes, not? So that's why I'm asking for confirmation, sir.
Sorry, I didn't get that. Sorry, what did you say? Sorry, what did you say?
Each presentation duration you said 5 to 7 minutes, no? That's why I'm
Yeah.
confirming how many.
Right. That you can, I mean, say within that you can say a couple of slides one person can talk about, and I leave it to you how you manage that time. Because the subjects are going to be, the topics are going to be very short, so you don't have too many things to talk about.
Okay, sir.
Okay, then if there are no other questions, we'll stop now.
Thank you.
Yeah. Thank you. Thanks. Thanks. Bye. And we'll meet again in the.
Thank you, sir.
Thank you. Bye. Thanks.